Okay, so now what we're going to do is we're going to do the proof of the fundamental theorem of calculus part 1. Okay, so we start by letting f of x be a continuous function over ab, and we're going to define f of x equal to this integral. The integral from a to x of f of t dt. Okay, so now what we're going to do is we're going to apply the definition of a derivative to capital F of x. Okay, so let's do that. So let's f prime of x equals excuse me, f of excuse me, oops, not a plus b. Okay, so f of a plus h, or no, x plus h. F of x plus h minus f of x over h. Okay. Oh, I'm sorry. Oh, I need to get some coffee. It's equal to the limit as h approaches 0 of capital F of x plus h minus okay. Now, what I'm going to do is I'm going to pull this constant out. So this is going to be the limit as h, oh boy, approaches 0 of 1 over h. Now, what is f of x plus h? I'm just going to use this. So this is going to be the integral a to x plus h of f of t dt, right? Minus the same thing, which is just going to be f of a to x of f of t dt. Now, what I'm going to do is I'm going to use one of the properties here because I'm subtracting. I'm going to change this to an addition. But remember, if I do that, I have to flip the limits of integration. So now I'm going to write this as the limit as h approaches 0 of 1 over h times the integral from a to x plus h of f of t dt plus, now I'm going to put the limits of integration to x to a of f of t dt. Okay, now look what I can do. I can combine them because now a is in between from x to x plus h. So I can write this as the limit as h approaches 0 of 1 over h of the integral from x to x plus h of f of t, oops, dt, right? So now, what happens to this thing? So look carefully here. So I've got 1 over h. H is the distance, right? So it's 1 over the distance from x. This just represents the average value of the function, right? Think about it. We're looking at the interval from x to x plus h, right? So this is just h, this distance, right? The range. So the h is like 1 over b minus a. b minus a is h, right? And we're just taking the integral from x to x plus h, to the length of the interval, right? So that really is just the average value of the function, f of x, over the interval x to x plus h. So therefore, well, let me write that out in the proof. So, 1 over h, the integral from x to x plus h of f of t dt is the average value of the function of f of x over the closed interval x to x plus h. Okay? Hence, the mean value theorem states or implies right? So the mean value theorem for integrals implies there must exist c in the interval x to x plus h such that f of c equals the integral from x to x plus h, 1 over h times the integral x to x plus h of f of t dt. Okay, now we also know that c is in between x and x plus h. And since this interval is getting smaller because the limit is taking h to 0, okay, so that means c is approaching x. Okay, so let's state that. I'm going to go back up to here. I don't want to crouch down. Okay, so let's go back up here. So now, since c is between x and x plus h, And what do I want to say? Since c is between x and x plus h, yeah. And h is approaching 0. C is approaching x. Okay? Also, since f of x is continuous, okay, since f of x is continuous, what do we have? We have the limit as h approaches 0 of f of c would be equal to the limit as c approaches x of f of c. Which obviously is going to be f of x, right? So now all we have to do is put this together. So if we put everything together, we get our final result. Okay, so what is that? We just showed that f prime of x is equal to what? Go back to the proof. What did we show? We showed that f of prime of x is equal to the integral 1 over h of the integral from x to x plus h of, hold on a second. Don't drop your limits. Is equal to the limit as h approaches 0 of the integral of 1 over h times the integral from x to x plus h of f of t dt, right? Okay. But, well, actually, f of x dx. Okay. So now, well, but what is this equal to? We showed that it was equal to f of c. Or not f of c, sorry. Keep track of my limits. The limit as x approaches c, nope, as c approaches x of f of c, which is then equal to f of x. And actually, since we already showed this is the same as when h approaches 0, we can just keep it as h is 0 to be consistent. So when we put it all together, what we just found is this is equal to f of x. So this is equal to f of x, so we can skip this piece. So when we put it together, we found that, hey, f prime of x is equal to this limit, which this is the average value of the function, right? And we found that, hey, since by the mean value theorem, there's a c in the interval such that f of c is equal to this. Okay? So that means that there exists a function such that this is equal to this, f of c, right? And so we also then showed that the limit as h approaches 0 as f of c is equal to f of x. So we just showed that f prime of x is equal to f of x. And that's the end of the proof. Have a great day.